Hello, in this video I'm going to be just investigating and looking into a socket that's gone wrong on my ancient Dyson vacuum cleaner. It has had its original plug removed and replaced. Now I replaced this, so if you look at it you can see that it's a bit wobbly like that. So I've got nobody else to blame other than myself for if this has been installed incorrectly. We'll soon find out exactly what the state of this is. This vacuum cleaner has stopped working. It was working, then it stopped, and I knew this was getting a bit on the wobbly side and I should have replaced it. So hopefully it's this, but it may not be. This is the original cord, and over the years it's got caught and there's actually a break here in the sheath. So it's not in the conductors but actually in the sheath. So I'm going to reduce it by about that much. So the first thing to do whenever you've got an issue like this is just to check the whole lead. And so I've got my fingers on the lead as well as visually looking at it, and I'm just pulling it through like so. I'm just making sure that there's no other nicks or breaks on this. And since I'm only losing a meter, I'm not going to replace the entire cord, but it is its original cord. So let me just put this all back in again. I like to put it in flat. I'll show you in a moment that this is oval cord. It's not. There's the brake, which I'll be taking off. So let's just take a look at this. So this is a standard British plug. This should be captured, the thing in the centre for a good plug, which it is. The fuse is to protect the cord. And you can see on this, I've got a 13 amp fuse on this cord here. So it's a 1200 watt. I'm not actually 100% sure what the wattage is. Let's see if I can see the marking on it. And it says 1200 watts. Essentially 5 amps. The cable itself is high temperature, 0.75 square millimeter. Usually with a 0.75 you're probably looking between 3 and 5 amps. It's certainly not a 13 amp. Because this is high temperature, you can get away with a higher rating of fuse because it's the insulation that governs the rating. So there's two things. One is the temperature of the insulation, at which point it starts melting, and the second thing is voltage drop. When you plug something in, you expect to be using the power that you pay for. Voltage drop is a thing that you have to look at, but it's not really a thing in this case. If you look at this, let me just pull that out again. Look at this, you can see why it's floppy. The sheath here is torn. It's actually torn itself. Now, a lot of sheaths do tear quite easily, so if you get a nick in it, it starts to have a tear that propagates, and in this case it's gone all the way round. That is one thing that I don't like about these type of plugs, and I'll talk about that in a moment. So let's just take this out now. Shall I use this one? So I've lifted the sheath, the clamp on the sheath, and I'll just take out the terminals. I've now taken these out and I should be able to just pull these out. So that shouldn't happen. This is supposed to be captured. It doesn't drop out. So it is kind of captured, but somehow managed to work its way out. Okay, so that's the standard plug, and we can see that in this particular case what happened was it ripped it loose. There's no continuity on this, and usually you would expect if it was metal fatigue it would have sparked and I would have noticed that the motor would be running all over the shop, going fast, slow, cutting in, cutting out, that sort of thing. and I would expect to see some heat marks as that part of the cable heated up, but there's nothing on this like that. And this type of stranded cable is known for its ability to be able to bend and not fracture. So let's take this out, and we'll go to that point here, and I shall cut it just there. Let's take a quick look at this to get the general idea of sizing. This time I'm going to use a plug that has a relief on it. It's clamped on the cable. The sheath of the cable is there to take most of the mechanical stress, and the conductors are to protect the integrity of the wires that actually carry the current. The other thing with this is, like you saw on the original piece, is to stop this kind of tear action. So it starts off like this, as a nick, and then it slowly propagates as you bend it like this. It gives you what's called a radius turn. It just opens up the turn, so you can't have it fold like this, like that, putting a lot of pressure, and it forces a radius turn, and that preserves the life. So you tend to see this in moulded plugs. What you find is when you buy these plugs, they rarely come with this part here, which I think they should. So let's open this up. And then this one. There's a few things. And then we'll just open up the other so that this thing can just swing across. And then we can just put this in like so. And then this through here. What's this? Back in? It's the neutral which I have to really think about, so let's just take a little piece off here. And I did actually have a wiring diagram on this, so you can actually see the lengths. So in theory that's not too far away, but I think what I need to do is just take off an additional centimetre like that, and then I'll just take off the end like this for that. And then I'll shorten this one again by about a centimetre, like that, and I'll take the opportunity to twist that. So I'm going to need to shorten this. Now certainly with wiring a plug you don't need to do this step, but I will because I can. And that is to use a bootlace ferrule. See? So there's the ferrules that have gone on the end. We'll just run this. Then we'll do the first one. Zoom this up. Sometimes it's easier to take the fuse out, and what that allows is this part here comes out, and it's just easier to use to wire it to this thing. Well, that fuse is all back. Right, that's short. Set up. I'm just shorten that ferrule. Actually, I just go backwards. So, like that. And it is up here. going to change that fuse to 5 amp. There's a 5 amp fuse which I'm going to use instead, and that's suitable for the cable. And then I'm going to do this part up, the strain relief. That's the main part of it done. The earth terminal is just going to drop in. This is not an earth cable, so it doesn't need an earth terminal or an earth wire put in. And then this goes over this, like so. And that's the thing done like so. I'll keep this little piece of paper and put that to the side, and then so that's that done. And let's see if this will work, or do I have other issues with my Dyson. So yeah, so it definitely was the wire that went. Just to note, there's a few things that I want to just talk about. Let's just put this back in. I just want to talk about the plug and just go through some of the features and problems of this type of plug. So you can see with this, somewhere along the line it lost conductivity. Let's see if we can just establish roughly where that happened. Right now we have this, and if I put it on the neutral and put that on the neutral, so the neutral doesn't seem to be continuous. Let's put it on the live and put this on the live. So let's just pull this back again, so where it is. So I'm just going to pull this like this and pull these like that. So I'm just going to twist that and twist this, and let's see if we can, is it in there? So I've got the live, which was good, so we know that's good, but the neutral appears to be the one that has lost its integrity. So yeah, nothing there. So is it in this part here? If I just pull these, there's nothing to give away that it's not coming out at all. So let's just cut the end of this and see whether or not it was just that little part there, and then we can just pull it back again like so. I'll twist the ends of those. That's a neutral. Whatever it was in this part here. Let's see. I'll put the neutral there. So it's still broken. So it's this neutral wire here. Look, you can see where it's flattened out. The reason why it didn't spark is because it's obviously been pulled and it's separated the wire, and it's pulled it apart so far that it couldn't even spark that gap. Or it got hot and it was pulled at the same time and it stretched it so that it couldn't rejoin again. There you go. That's the reason why it stopped working. So as far as this is concerned, there's a few things that you need to know. The sheath of the cable, which is this, is not the same as the conductors. The metal part of the conductor, and then you've got the insulation of conductor, so that is the conductor. And then you've got the sheath, which often is considered as an insulator, but is predominantly a mechanical protector as opposed to purely an insulator. So it has insulating properties and it is quoted often, but its main purpose is like a mechanical protection against the conductors. So that must go under here and be clamped like this. It should never be in a situation where it's loose like this. And you can see what happened. So arguably I did the job properly. I may have clamped it just a little bit too tight, and over time a tear has happened and then it's propagated through. Even when these are closed, like so, now you'll notice that there's like a little shutter here, and if I close this like that, you can see the conductor for this down there. You shouldn't see that. Now when the cable's in there, the cable kind of gets in the way and it makes it very difficult to access, and with that little door there's a little lip on there that just forces that to come out to hide that conductor there. So you can't see these other conductors because they're at an angle and the route of the cable means that they're hidden, but the live conductor often is the straightest route from the end, and so when you look at it like this you can often see the conductor there. Now with IP rating, to get the highest rating, I believe, is a 1mm diameter rod which can be inserted in there. So basically like a paperclip. If you can put a paperclip in there and touch this, the live, and live is always on the right on these, then it lowers the IP rating. So you can't put your finger in, even small fingers can't get in, but you could get a conductor pushed into that. So some of these are actually not as well designed as you think. And like for instance the one that you just saw that I had, so something like this, you can see that the shroud on there, like for instance this also has a little door, but this thing here means that you can't push a 1mm object in, so this is basically the highest standard. Another thing to say about the fuse, and this is again something you never hear mentioned, is that this will dissipate a maximum of 1 watt at its full rating. When this is taking 3 amps, this will dissipate 1 watt in heat. It doesn't sound like a lot, but it is quite a lot, and over time it noticeably gets hot. Obviously these melt when they get to a certain temperature. The internal wire on there will melt. So when you're talking about 1.52 watts that you're going to have on these, and I think it really does need to get to about 2 watts before this will actually melt. So it's almost twice the rating of the fuse. There's a time for it to pick up the heat within that. So if it, say for instance, has a really quick high power, like a second, it probably won't blow. Okay, let's put that back together again. Another thing to note, and I've seen this is very popular, like a lot of these fads, you get people saying, like for instance this had one of these on it, and the reason this is put on there is nearly all plugs that you'll see like this that are not moulded. A moulded plug like this, you can see the relief is built in, you cannot take these things apart. The rating of the fuse can be seen here, and it will say 3 amps, 3A. And you can get these different ratings like 5 amps. The standard fuses are 3 amps, 5 amps and 13 amps. But you can actually get in between those. But it's the cable itself, and this cable, even though this is a 3 amp plug, so it's got 3 amps on the moulding, that means you must use no more than a 3 amp fuse on this. So irrespective of the cable or the end, so this is a 10 amp plug, this is a 13 amp style plug, but the rating is actually put on as 3 amps, so this must be 3 amps. You don't go by just the cable, you go by the lowest rating of whatever the component is. So the manufacturer stated this is 3 amps, so it's 3 amps. Whilst most removable plugs that you have, often they're 13 amps, and they'll say 13 amps. So to stop it being 13 amps to tell the customer they supply this overlay. Now this is one of those things that will divide the room. Just put this back on. The one that was on this was 13 amp. This already says 13 amp. Right there you'll see it's 13 amps to 50 volts. That's the rating of this. So this thing here really is just the wiring, but it also has the fuse rating on it. On this one, this is actually a 3 amp cable on a 13 amp plug. So I could quite easily change that fuse for a 13 amp fuse by accident. So what they do is they provide this piece of paper to cover this, and it has the fuse rating. If you look at the rating on this, you can see that that is 13 amps, so it's 13 over 250. This says it's 3 amps. Now a lot of people will tell you to take these off and throw them away because they're a liability, and I have to say that I can't understand that. Even if this is wet, you see these insulators here, it's not going to allow leakage or any sort of current to go across from there. Second of all is I've seen somebody say the thickness of this, if it's 1 or 2 millimeters, could cause a problem with plugging it into a socket. That would be true if this was 1 or 2 millimeters. Let's take a look at the size of it. Let's just zero that. I'll just put this on, and we can see it's about, let's call it 0.5 millimeter for just the sake of easy math, but you can see it's 0.4 millimeters or 0.3. Well, you can see the numbers on there. If we were to make this 2 millimeters, okay, that's close enough. You can see that's quite a big gap. You would need probably 4 or 5 of these before it even came to that, or possibly even more. The other thing is, anybody who knows anything about starting a fire will know that you need air. So this is technically a combustible surface. I'm sure it will burn if I put a flame to it. I don't think there's any fire retardant in there. But if I push this like that, you'll see that there's no gap. There's no gap at all. Which means that I would say I cannot see or envisage a situation where that would catch fire. You would have to have the plug out like this, so that there's now air that can get underneath that, and the conductors won't make properly, and they would probably are. If you had a fire like this, it would probably be because the socket is not being pushed in properly, not because of the piece of paper. And even if the paper did catch fire, because of the materials that these things are made of, they don't burn. They can get incredibly hot, but they will not burn. They will char, but not catch fire as such. And you'll notice with this, when you put it on, you have access to the terminals. So 2 things. If this was dangerous, the manufacturer would put on, they would have a thing that says remove it, which they don't. Second of all, why would you spend the extra time putting holes in it so that you can access these screws whilst the piece of paper is still on, if you were supposed to throw it away? And also, once this is gone, you don't have the marking at 3 amps, and I know for a fact that most people don't really think about the cable. Looking at the cable, looking at the rating of the cable, they will just put in the first thing that comes to hand, which is invariably a 13 amp fuse, and put that in there. So they've overrated the socket to the cable. So yeah, okay, so that's just a little bit of a bugbear that's rolling around in my head that I need to get out. That little piece of paper, doesn't matter if it stays on or you take it off, but when people sort of make out as though it's, you know, you're dicing with death and it has to be removed, and when they're going to do pat testing as such, they take these off and rip them up. No, don't do that, because it's got the rating of the fuse on it, and that is probably more serious than the likelihood of this catching fire. Okay, so anyway, that's me off my soapbox, and thank you for watching.